Hello, welcome to another Sneak Live. I'm your host, Brian Clark, go by Clark on the interwebs, and you're tuning in for another Stranger Danger session. No, don't talk to strangers. Watch out, beware. Something like that, right? You learned it as a kid, maybe? I don't know. In any case, I'm not going to be teaching you about this, and it's best that I don't because I always talk to strangers. All right. Enough of that. Anyway, moving on. So for today's session, Stranger Danger, we have the amazing Sonia Moiset that's going to be teaching us about how our JavaScript attack surface is getting bigger and the security related to that. She does an amazing job of this. It's my favorite version of our Stranger Danger sessions that we do. So without further ado, let me bring her on. Hey, Sonia.
Hey, hi everyone. Hi, I'm Sonia. I'm a senior security advocate in Snyk, and today I'm going to be taking you through today's session. Stranger Danger, your JavaScript attack surface just get bigger. So yeah, let's jump onto it. Cool.
Sure.
So what are we going to talk about today? So we're going to have a look at what is the current state of open source software. What are the hot topics? We're going to have a look also at the iceberg. And you might be wondering, like this little emoji, what is the iceberg? I'll explain it to you. We're also going to do some live hacking with the help of Patch. Patch is our little mascot, little dog. Obviously, we're going to remediate all of these vulnerabilities, and we're going to see the learnings and some defense in depth tips. Cool. So let's start with the current state of open source security. So we know that organizations of all sizes are heavily reliant on software, and that much of that software supply chain consists of multiple open source components. And therefore, this implies that the open source software has cybersecurity implications because this is an attractive entry point for people and organizations interested in theft, disruption, or exploitation for economic or political gain. And thus, the attack surface is changing. And we know that this is changing from the traditional cybersecurity threat models. And we've seen it with defects in small libraries can cause systemic risk. Like, for example, last year, we've seen it with Log4Shell incidents. So vulnerabilities can originate from something as simple as a configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for businesses. One recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw, and of these, 20% have severe vulnerability. While we know that not all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate softwares. And we have organizations such as OWASP, which stands for Open Web Application Security Project. That organization tracks vulnerabilities found and provides a list that developers and security teams can use as a starting point for their application security program. They usually release that list every 2-3 years, and we had the most recent list, the OWASP Top 10, that was released last year, 2021, and included broken access control, injection attacks, security misconfigurations, and other vulnerabilities. So let's have a look at some of the open source software attacks. The first one is typo squatting attacks. Typo squatting attacks take place when bad actors push malicious packages to registry with the hope of tricking users into installing them. This is really similar to website phishing attacks that exploit typos made by individuals who may accidentally type in a wrong address. Here we have an example with the package React, which is, you can see with a typo. In that case, you will not install React, but a malicious package that has a completely different end goal. Usually, it's to exfiltrate some data or some sensitive information from your server. Another example is malicious packages which inject malicious code into a software product in order to compromise dependent systems further down the chain. So in this specific example, we're having a package which is called Fall Guys, and usually the malicious actor will try to surf on trends. So we know in that case that a game like Fall Guys has been quite popular during the pandemic, and users might think that by downloading this package, they can get an advantage within the game. So Fall Guys, as I said, is malicious package in that case because it contains malicious code that attempt to read local sensitive file and exfiltrate information through Discord webhook. That was the entry point that we're using the Discord webhook. And basically, the code attempted to access specific path available on Windows system. It was just looking at the local storage and exfiltrate your information to that. One last example is compromising maintainers, where malicious actors will use social engineering methods to gain access to open source projects. So we had an instance with the event stream package where the malicious actor did social engineering the maintainers. So basically, he went through all of the issues and tried to find an issue where he could potentially push code. But first, he pushed some cosmetic changes. So at first, he pushed changes on the CSS files, on the README file, just to build up the trust with the maintainer. And once he got more permissions, then he pushed his malicious payload into the code base, and this was targeting Bitcoin wallets. So his modus operandi was interesting in going through all the issues and see if he can contribute, build up the trust, and then push his malicious code. So this is known as a supply chain attack, also called third-party attack. It occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. The bad news is it doesn't affect only JavaScript packages. This is an issue for all ecosystems. And we had a recent example with Log4Shell last year within the Java community with a vulnerability in the open source Apache Log4j logging library. And this has earned the vulnerability a severity rating of 10 on the CVSS scale, which stands for a Common Vulnerability Scoring System. So supply chain attacks are attractive to hackers because when commonly used software or packages are compromised, the attackers could potentially gain access to all the enterprises that use that software. So let's try to understand how this is possible, and let's say hi to the iceberg. And by the way, if you're confused by that statement, let me explain it to you. So that's the iceberg. And you might ask, okay, that's cool. So yeah, that's just an iceberg. What's going on? So let's look at the tip of the iceberg, the application code. This is our starting point. So this is our code. This is the proprietary code that we write in an organization. Does it bring security vulnerabilities into our code base? Maybe. So in that example, I'm going to showcase NoSQL injection because we're not sanitizing the user input. So what happened is we have a function signature of an Express application with a function that has a request, a response, and an next callback. So it's calling the user table or a collection, which means that there's a database behind the scene. It's trying to do a login, so looking for the username and the password. So what are the vulnerabilities here? What can go wrong? So we have a database injection. In that case, it's more specifically NoSQL injection because we're using MongoDB and backend. And the application built with Express will have a body parser to parse the JSON object and takes whatever you send to and convert it to a JavaScript object. If the request has a username and a password, this is going to be part of the JavaScript object. And if you're using MongoDB and add the $ greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do a greater than mesh to filter all the results, and you'll be logged in as an admin on that case. So this shows the importance of sanitizing inputs and to handle it as soon as possible before it's stored in your database. So we start with our application code, where potentially we can have security vulnerabilities, as we've seen. And this is a piece of code to import a dependency. In that case, this is marked. We'll talk a little bit more about marks later on, but this is actually a nice segue to the layer below the application code on the iceberg, the open source layer. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we realize that we don't reinvent the wheel. And this is totally understandable. Why would we want to waste some time to rewrite something that might probably exist as a package in our ecosystem? That's why we have here with the Mark package, and you can see more packages around because we need to implement several features, and we don't want to write all that code. But we're now bringing several packages into our code base, increasing the attack surface and introducing new risks. So are we aware of all the packages that we have? Are we aware of all the dependencies and sub-dependencies? Do we have a good understanding of indirect and transitive dependencies? Do you have tools that help you having that level of understanding and visibility? And also, what are the risks when you bring a dependency in your code base? I know, that's a lot of questions, but let's see some numbers around that. So these are a few numbers of security challenges in the OSS ecosystem, as we can see. So we have an average number of outstanding and critical vulnerabilities in an application, which is around 5. And this ranges between 2.6 and 9.5. This is based on programming language, obviously. We have also an average dependency per project of 80 top-level dependencies. But the most scaring number is the last one. The average number of days it takes to fix a vulnerability is around almost 100 days. So enough chatting for now, and let's move on to hacking an application and understand more about how dependencies can impact your application and introduce new vulnerabilities that you were not aware of. So I'm going to ask Brian. I have 3 vulnerabilities to demo today on this application from the front end. Which one do you want to see first? So I have a path traversal. I have one around store XSS, and I have one around prototype pollution, which is a new one that I've worked on.
Ooh. Being that it's newer, I'm thinking let's go with prototype pollution. I don't know that is as widely known for JavaScript developers, so let's check that out.
Yeah, that's a good one. Cool. So first of all, the application that I'm going to use is available on the GitHub Sneak Lab. It's called Node.js. If we can zoom here, yeah, this one. So when you git clone and install it, you should have this to-do list, this patch to-do list here. So yeah, this is like a classic to-do list, but this is not the thing that we're looking, because you actually asked for the prototype pollution. So in this application, we have chat endpoints. Let me just zoom in here. So as you can see here, there's a lot of endpoints. This is a vulnerable application, so there's a lot of fun trying to tamper with that one. But let's have a look at the chat endpoint. So if we look at the routes here and here, so basically as a regular user, I can post messages, and as an admin, I can post, and obviously I can delete messages. So as a regular user, I can't delete messages. But because we're using Lodash in that application, and you can see more specifically, we're using the merge function on Lodash. So for those of you who don't know Lodash, the naming convention, we're using the underscore and the dot merge here. And this specific function is actually vulnerable to prototype pollution. I'm going to explain what is prototype pollution after, but just wanted to demo this first. So let me open a new terminal. Let's have some fun with that. So first of all, for a sanity check, I'm just going to show you what the endpoint looks like. Fancy. It's just an empty array for now. So back to the terminal. For sanity check, I'm just curling the page that I've just showed you. So I'm doing a GET request to that specific endpoint, and I'm getting back an empty array. Cool. So now as a user, I'm going to try to send a message. So again, I'm sending a PUT request in the same endpoints. I'm using the content type of application JSON as a header, and the message would be just adding hi here and sending it as a regular user. I'm having the answer back like, okay, true. And if I refresh the page, I should see the message here. Little icon and hi. Cool. Just going to do this a couple more times to have more messages. And when I refresh the page, I have 3 messages. Cool. Okay, so I'm going to try to delete now one of the message, but I shouldn't be able to do this as a regular user, right? So I'm using the delete request here, same endpoint, and I'm targeting message ID once. I want to delete the first message. So let's see. I'm getting access denied. This is what I'm expected to receive back, because I'm a regular user. Okay, so let me put my attacker's hat and let me tamper with this object. So I'm doing the same PUT requests with the same endpoint with content type application JSON, but here you can see something different. So obviously I have like the little noti emoji here, but most importantly, I'm using this key proto, and I'm going to explain why just after this this attack, what is going on here. But bear with me for a second. So I'm using the proto key, and the value is can delete true. So which means that by injecting this this key and value, I'll be able to actually delete the messages. So I'm getting an OK true message back. And if I refresh this page, I should see. Yeah, so cool. So now let me try to delete now that I've tampered with the object. So if I try now to delete with the message ID of 1, I'm getting true now. And if I refresh the page here, the first message disappeared. Let me just remove the other two messages. So if I do message ID 2 and message ID 3, and I only have my message here.
That is evil.
Yeah,
Very
that's why. The whole emoji here.
And just a heads up, sometimes I'm noticing there's a little bit of delay with what your screen is showing and then what you're saying. So just a heads up on
Okay.
that. Give it like a 2-second delay for it to show up, and then it'll be there. That's
Sure.
wild.
Yeah.
That is very evil. Why is that possible?
So that's a good question. Let's have a look. So I've mentioned that the Lodash package was vulnerable, but first of all, let's ask the help of patch. So I'm gonna install the Sneak ID integration within the VS Studio Code. That's the one that I'm using now. So if you want to install Sneak, you can go to the extension tab here and type Sneak, and you can install it here. That's the first result. You install it, you enable it, and you have to reload your ID so it's taken into account. And then the first time you won't see this screen. You'll see a little patch icon asking you to authenticate. So if you have a free account at Sneak, you can authenticate and start the scan. So after that, once you've installed the integration, you can run the scan by clicking this little icon, triangle icon here. And if we have a look at the Lodash package here, you can have a look here at the different vulnerabilities that we have, but also from your package JSON. Let me just close this one here. Yeah. So if I go to the package JSON and look at, just going to zoom this. Yeah. And have a look at Lodash, if I can find it here. You can see there's a yellow light bulb, and if I click on it, it'll show you the most severe vulnerability. And so in that case, this is a command injection. But here, I'm more interested in the prototype pollution. So I can go back to patch and have a look at what is going on. So if I click on here, prototype pollution, there's a little bit more of explanation of what is the vulnerability and what is going on. Cool. So they'll give you a little bit more explanation on the Lodash package. So for those of you who don't know, Lodash is a modern JavaScript utility library delivering modularity, performance, and extras. And we've been using the merge function in that case for the application. But if we have a look at the prototype pollution, so this is a vulnerability affecting the JavaScript ecosystem, and it refers to the ability to inject properties. As we've seen in that case, I was able to inject the can delete true property into the existing JavaScript language to construct prototypes such as objects. And the JavaScript allows all objects attributes to be altered, including their magical attributes such as proto, constructor, and prototype. And in our case, we're using proto actually to tamper with the objects. Cool. So now that we understand a little bit more what is going on, obviously we want to fix that. So let's go back to the package JSON and let's change the version of Lodash. So now we have 4.17.4, and we're going to upgrade the package to 0.20 here. So let me just stop the server first and do an npm install here to make sure that it's taken into account. Cool. So we're upgrading this this package to fix the prototype vulnerability in that case, and hopefully, as a regular user, we won't be able to delete the messages. So if we go back and refresh, this message should disappear. Oh, it also I have to refresh, restart the server. Yeah. So going back here, and yeah, we're back to the empty array. Cool. So let's go back here and let's try to populate some messages and do the same just to see if we fix the vulnerability. So I'm going to put some messages here just to populate. Yeah, so we're having some messages. Cool. And then I'm going to try to delete the first one. Oops. So I'm going to try to tamper with the first one. Okay. And then I'm going to try to delete the first message. And here you can see that the access is denied because you're not supposed to delete. So this has been fixed. And if I go back here, I can still see the little hacker message, but the hacker can't delete the message anymore. You can see that the message number 1 is still here. So we fixed it. Yay!
Woo!
Cool. Let's see.
Crowd cheering sounds effects that normally would work, but
Yeah.
I don't have them set up, unfortunately.
Yes. that's fine. We fixed it with the help of patch. Cool. Let's see another vulnerability. Oh, that's okay. I'm going to show you the traversal, path traversal, directory traversal vulnerabilities. So basically, everything is happening here at localhost 3001. Yeah. So imagine you have your application served and hosted somewhere, and as an attacker, I would like to tamper with the URL and see if I can traverse directories and see if there's any sensitive info. Obviously, you shouldn't be able to do that, but let's have a look. Cool. So if I put public here, so I can see that I have access to the public, the assets files here. So I have access to CSS, JavaScript, robots. Okay, cool. Which is not great. This is not usually what we want to see in our application. But let's try to go up with the // This is to check the parent directory of the current directory you're in. Let's just do // and we're back to the front page. Okay, so there's some sort of sanitization going on, which is good news. But I'm a clever attacker, and I'm going to try something different. So I'm going to try with URL encoding, basically. So for those of you who don't know what is URL encoding, I'm just going to go to this page. And basically, I'm going to change. Oops, just going to here. Yes, I'm going to change the // with this. So the dot would be this percent to E, and the slash would be the percent to F. So let's try this. So I'm going back to /public and / just going to copy paste to make sure that pasting the right thing here. And oh, what is going on? Okay, interesting. Yeah, I'm on the server. So basically, I'm on my machine, obviously. But imagine if your application is serving on the server, you'd be able to actually see what's going on in the parent directory. So let's try with this. Let's continue. Let's go up another level. And okay, we have a more folders, more information. Okay, I'm a curious attacker, so let's see if we can go up another level. Okay, yeah, this is actually working, and I can see the etc folder here. So for obvious reason, I'm not going to click on it because this is will show so some passwords. I don't want to leak any sensitive info. I don't want to leak any sensitive info.
Go ahead, no big deal.
But you know where I'm going. So yeah, as an attacker, I'll have access to sensitive info, obviously the etc with password and other things from your system. So what is going on in that case? So let's go back to the code. So, and we're gonna also ask the help of patch in that case. So for this, we're using, if I can find the right file, yes, we're using st, which is a package for serving static file. So requiring this st package here, and we are instantiating it here. So you can see this is where we instantiate the package. Cool. So this package has a vulnerability, and let's see what it is. So if we go to package.json, and if we go to the st package, we can see this yellow underline. And if we click on the yellow light bulb and show the most severe one, we're having open redirect in this case, but this is not the one we're interested in. Patch, you're not helping today. You're showing me the one that I don't want to showcase, but that's fine. Let me just find it here. Oh, I think I need to rerun the scan. Okay, because this is from the previous one. That is fine. Let me run. So I can showcase actually how to rerun the scan. So if you click here, it actually takes a couple of seconds to do a scan of all your packages, and we should see. Yeah, this is what I was expecting. Cool. So this is not okay. This is not patch fault. It's mine actually. I should have run the scan. So if I go back to the package JSON, and if I click on the yellow light bulb, yes, this is what I was expecting. Thanks, patch. Cool. So everything's fine.
So really
Directory
quick
to
there,
Wilson.
Sonia, really quick there, just to make sure everybody's following along. So the extension, it can be configured to scan automatically rescan things for you, right? As things change. So you updated the package version and it hadn't been scanned yet, and that's why you didn't see the result.
Yeah, just to make sure, click on the little rescan icon. So you
Yeah.
have the latest one, and it will scan again your package JSON and make sure that it actually shows the vulnerability that you have within your code base.
Okay, cool. Thank you.
So in that case, we're having directory traversal vulnerability, which is introduced through this version of package, and it's fixed in the 0.2.5. So what is happening here? This is telling that the version prior to 0.2.5 didn't properly prevent path traversal. And this is what we've been using, and we've seen that actually we had access to sensitive files and data from the server. So what is a directory traversal attack? This is also known as path traversal, and this is aimed to access files and directories that are stored outside of the intended folder. And this is by manipulating files with the // sequence and its variations, because we were using actually variations with the %2e and %2f for the // And in our case, we're having information disclosures. So the attacker will gain information about the folder structure and read the contents of sensitive file on the system. And we don't want that. So let's fix it. So let's go back to the package JSON, and patch told us that we need to change the version from 4 to 5. Cool, so let's do this. Let's close the server. Let's do another npm install. I'll make sure to restore the server after that. So what I'm doing is upgrading the ST package to make sure that the path traversal vulnerability will be fixed. So let me just start the server again. Cool. And now if I refresh that page, I cannot get that specific path anymore. It's been fixed. Yay! Another one that we fixed with patch.
Yay! Crowd goes wild. Woo! Confetti.
Cool. Whoop. Let me just go from here. Cool. So what did we learn here? So we learned a few things. I'm just going to turn back to you. So we can actually use the Sneak Advisor before implementing a package within our code base. And let's have the marked package in our case. So here we're on the Sneak Advisor website, and you can see with the drop down, we actually have different ecosystems. So we have npm, Python, Go, and Docker. In our case here, we've selected npm. And if we have a look with the marked package, this is the first result. And actually, this is amazing because it has like a perfect health score. Obviously, the one that we've been using in our code base is vulnerable, just for the purpose of the demo. But the latest version is free from security vulnerability. But by using the Sneak Advisor, this will give you information around 4 dimensions. So not only security, but also popularity, maintenance, community. And Sneak Advisor is free. You don't need to sign up or the only thing, you can just go visit the website and just enter your package to have that kind of information. So you can see the security, if there's any security vulnerabilities, the popularity of the package, the maintenance, when was the last release, when was the last commit, and also the team, the community team who's contributing and maintaining the package, and other information around the package. So we can have a look like, because we wanted to implement Markdown. So if you're not sure, you can also type Markdown and you'll have different packages. So let's see the first one, Markdown. And you can see the health score is completely different here. There's security issues found. The package is not as popular as the one that we've seen. last releases was 9 years ago, last commit was 4 years ago, and we have other info. So this will help you actually to make some decisions before implementing a package within your code base. Also, you can use, so depending on your familiarity with the CLI or the ID, I've demonstrated the ID integration, but you can do exactly the same with the CLI. So let me just demo this for using the Snyk CLI. So if I open a new terminal and just do Snyk tests, this will query the vulnerability database and come back with the exact same vulnerabilities that you have if you click the little icon patch. This is exactly the same one. The good thing here, you can also filter using the severity threshold. If I can type it, severity threshold with high. So in that case, this will give us only the highs and critical. If you don't want to have the other level of severities, yeah, as you can see, this is all red because this is only the high severity in that case. So depending on the way the workflow you're working with, you could use either the CLI or the ID integration. And also you can use the dashboard, the UI, and have that visibility on the Snyk dashboard if you import your projects. So in that case, you will have your project monitor automatically. And if there's any new vulnerabilities introduced in your application, you'll be notified. So just to showcase this as well. So this is your dashboard. So if you add a project here through GitHub, you'll click on GitHub or any other sources where is your project. Then you will import it, and you'll have the scan that will kick in, and then you'll have your project here. And this is the one that I've been demonstrating in Node.js goof. And if I click on the package JSON, you'll have exactly the same level of details that you have on your ID or on the CLI. Cool. So yeah, as I said, you'll have that same level of details, and obviously you want to fix the vulnerability, and you can do so through the dashboard. So if you click on the fix this vulnerability green button at the bottom, you'll be redirected to open the fix PR. So you can do either you can cherry pick which vulnerability you want to fix, or you can just do a bulk fix on it. And obviously you'll have to go through the PR to see if there's any breaking changes. But yeah, you could fix your vulnerability through that as well. And you also have the education piece to learn a little bit more. So with Snyk Learn, so usually for these vulnerabilities, you might see some links just to learn more about this vulnerability. And if you go on Snyk Learn, you have, depending on the ecosystem that you're using, different vulnerabilities. So let's see, directory traversal, for example. You'll have just a one pager of what is the vulnerability, and you can try the vulnerability within your browser. It's sandbox, so it's safe to do some experiment with that vulnerability to learn a bit more about it. And because you can also log in and keep progress, you can see those like progress bar. I'm actually learning a little lots about vulnerabilities here. But yeah, you can keep progress on Snyk Learn. And also this Snyk Learn is free website to learn more about vulnerabilities. Cool. So let's go back to our iceberg, because we have a few layers to look at. So the continuous layer. An application needs to be deployed everywhere, somewhere, or somewhere. And we're using containers and static website to deploy our projects. So we're using different ways to do so. We could use Docker, Versal, Netlify, cloud providers, and we're adding a Dockerfile now in the equation, which has metadata about your projects. So this is their additional layer with modern application, and we're running our application as Docker images, and this adds to the complexity and increase your attack surface. So Snyk can help scan your Dockerfile, and as you see with the Node.js goof, because there's a Dockerfile, this will appear when you monitor your and when you import your projects. So let's go back to basic Dockerfile, and let's see what could go wrong with this. Well, a lot of things can go wrong, and I know this is a really basic Dockerfile, but let's see what are some security issues with this Dockerfile. So the common software vulnerabilities. So for example, if we're installing the ImageMagick, this could potentially bring vulnerabilities within. And ImageMagick, this package has a lot of security vulnerability. They actually created a dedicated website to explain more about what was going on with those vulnerabilities. And it ranged from the XML injection to remote code execution. Another layer of vulnerabilities when you do run npm install might probably have dependencies which are vulnerable. What we would recommend is to run with the flag only production to avoid pulling dev dependencies and non-deterministic package install. Also, the runtime vulnerabilities, for example, from nodes. Are we looking at security releases? Are we doing this due diligence to look at the security built-in? Because if we're picking a large image, it might have many vulnerable libraries. So on the Snyk dashboard, we have recommendation for upgrading the base image. As you can see here, if we're using the current image node 10.4.0 with a lot of criticals and high, we could potentially use a slimmer image, which might have less vulnerability. And also, we could recommend to have a multi-stage build Dockerfile. So basically, when you're in the development stage, you could use a bigger, larger image where you could experiment and have use of all the features. And then when you move to production, you can have a slimmer image with less security vulnerabilities in it. And we can do the same with the Snyk Advisor. So let me just demo this. So if we go back to the Snyk Advisor, and this time we change for the Docker and have a look at the node image. Here, if you click here, we can have that kind of information depending on the tag that you're using. You can see the number of stars, and if it's a popular package, obviously it's this is just insane, almost 4 million downloads. That this is giving you the kind of information that will help you make decisions of which image and which tags you should use within your code base. And we also produce cheat sheets on the Docker image security best practices. And as I've mentioned, we recommend to prefer minimal-based images and use multi-stage builds for small, secure images. Let me demo now. Demo time with the image tragic vulnerability. So yeah, first of all, let me show you the dedicated website that I've actually made. So it is called imagetragic.com, and they're just explaining that there are multiple vulnerabilities in ImageMagick, which is a package commonly used by web services to process images. So you could use it to resize images, for example. And one of the vulnerabilities can lead to remote code execution if you process your submitted images. So let's have a look with this one. I'm just going to open a new tab. Cool. So first of all, I'll need to build the Docker image just to make sure that I have, whoops, dash here. I'm just recreating a new clean image for that, just to make sure that the demo will work, hopefully. It's really take a little bit of time to recreate the image, but yeah, probably need a little bit of music here. Come on. Almost done. It's always long as you run npm install, right? It's like a lot of dependencies.
You know, you go stop by the water cooler, get some coffee or something, you know.
Yeah.
Tasty.
Here you go.
Delicious. Done. Perfect.
Done. Cool. So let's create that image. Cool. And it's listening on Perth. Yeah. Cool. So as you can see, we have a really fancy application here where we can upload an image to convert it to their ideal photo size. Cool. So what we're going to do first is I'm going to upload, if I can find it here. Yeah. Just going to close this. I'm going to upload this first payload. So it's basically using the API from ImageMagick. But this is the bit that it's interesting. So we're having the first bit of the payload is the image link, but then here you can see after the grep, the pipe symbol, we're going to create a file called rc1. So let me set up the scene. This is the interesting bit. I'm just going to create a new window. I'm going to split the terminal. This is where I'm gonna I have to get the black hoodie because I need to set up the scene. So, okay, the first window is actually to spin up this one. So the first one on the left is to spin up the local static server to serve the netcat package. So I'm going to serve it. Oh, first of all, I need to I need to see the exploits folder, and then I'm sorry. Cool. So we don't need this window to be big. This is just the server. Cool. Here we have this window just to actually connect to the Docker container. And just for a sanity check, who am I? I'm root here, and what is going on here? You can see this is just like the normal. This is basically, I can show you. This is what you have here, the same architecture, nothing fancy. This is just to showcase like before, because with the payload that I've shown you, when I'm going to upload the image, we'll see the RC1 JPEG here. Cool. So let's do this. Let's go back to this file, and let me just go and nice, this one. Cool. RC1. Okay. I'm just uploading the image because I want to resize this as a Twitter ideal photo size. Let's do this. Okay. Image resizing success. I don't know if it's a success because I have a broken image here, but let's have a look at what is going on here. So if I do, I'm just going to minimize this one. If I do another LSLA, I can see now here that I've implemented this. I've actually created the file RC1. And you might ask, so yeah, that's cool, but it's not really, I mean, yeah, it's a bit disturbing to create a file on the Docker image, but yeah, show me something more interesting. Well,
yeah, come on. That's not that interesting.
I'll say hold my drink. Wait. Okay, so let me just show you the second payload. So here we're actually going to create a remote shell. So I'm going to upload this file. So before that, I'm just going to make sure that I have everything running. And in this case, we're also using the first screen here, because you might be wondering, why do you split like 3 screens? Well, this is because I'm actually running the Netcat server here. So I run Netcat in listening modes, and I'll wait for incoming connections. Now I'm going back to the application. I'm going back to this one, and I'm going to choose the file, and this is the remote code execution file. Let me resize that one, and you can see that here is hanging here. Okay, so this is not great. So usually when you have your website blocked, something is going on. Yeah, this is a little bit concerning at the top of the screen. So let's go back to the codes. I'm just going to put who am I here to make sure that is coming back. So basically here, we're going to have to wait about 10 to 20 seconds for the Netcat utility to be downloaded from the local static file server here. This is from the first screen. Compile and execute it. And meanwhile, when it's doing this, I can actually show you that some stuff is happening here. You can see here like magic and some stuff here. You can see like the bin bash. This is not a great sign. Stuff is being copied over, and yeah. So it's been compiled and executed to then create a reverse shell. So here on the third screen, that will allow us to interact with the local Netcat listening prompt. So hopefully we're having it back. Come on. Takes a little bit of time. Probably we can have another coffee. Oh, okay. Wait, Brian, look, I'm root. What is going on?
No.
The remote code execution is successful. So first of all, let me just change this this prompt, because this is not great. So I'm just checking if Python is actually available here, which is. And what I'm doing is actually doing like importing the bin bash just to have it a little bit more prettified, if I can. It's working. It is.
So you have a direct connection now into that host machine of the application. And you can just do whatever you want.
Yeah.
Now that's scary. I haven't seen that one before. I've always done the RCE one, but I've never done the RCE two. So that's really cool.
Yeah, so basically now that you're root, and I think it's stuck, but that's fine. So the purpose of this demo is you can see I'm root because I was root on the container. So I'm root on my server, and basically I can just navigate through all the folders and see if there's anything interesting, and I can exfiltrate it to my own computer, my own server. So yeah, that's the demo for the RC.
That's very scary. That's a big deal. Shoot. All right.
Cool. Let's move on to the last layer. So we had the code, the application code layer. We've seen the open source code layer. We've seen the continuous layer. But then there's one last layer that is missing. So the last layer is the infrastructure as code, and it's an approach to manage data center storage and networking infrastructure. So it's meant to simplify large-scale configuration and management, and you're basically provisioning your resources through code, and it's your single source of truth, where you specify explicitly through code all the infrastructure specification in your config file. You can use version control, and you can test and monitor your configuration, which is amazing. Everything is great with ISC, but as a bot, cloud misconfiguration. This is the number one most common vulnerability organization will face, and this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. So you can see a few numbers at the bottom of the slides. So PlayStation Network had 77 million accounts hacked. Uber also had 57 million customer and driver information breach. Because they had one of their repo was public and they had AWS creds on it. And FedEx had 119,000 scanned documents in part of their breach. So the modern application. Oh no! Before that, let me, if we have time, let me just quickly showcase the Snyk IAC, because this is really cool. So we can use Snyk to actually scan your. In that case, they will be. This is a Terraform file. So here we have a really basic Terraform with for the provider AWS. We have the IAM account password policy here, and you can see this is commented out just for the purpose of the this demo, but and other services. So we have VPC, we have storage, CloudTrail, and the keys. So if we do if we use the Snyk IAC test, it'll go through your Terraform file and let you know if there's any misconfiguration, which is quite cool. So in our case, we have 9 medium, 3 highs, 0 critical, which is cool. So let's have a look. Here, so because we're using AWS services, so we have misconfigurations around S3 buckets, CloudTrail, credentials. What I'm interested in here is the IAM password policy. So it should contain symbols, should contain lowercase, uppercase. Okay, cool. So let's fix that. Just remove the hash sign here. Cool. And I'm going to rerun the Snyk IAC test, and we should see a different number of issues, total issues at the. Yes, so we've actually fixed 4 issues by actually defining a proper IAM account policy, password policy. And obviously this depends on your InfoSec policy that you have within your organization. Cool. So if we have a better look at some of the these issues, there's actually some links, and you can see rule, because we're actually checking those rules against the CIS benchmarks. Let me just close this. So the CIS benchmark stands for the Center for Internet Security, and they have those guides and checklists that you can check against to make sure that your environment is following those guidelines and have rules implemented. So in our case, we're checking against the IAM rule set. So here we have IAM password should contain uppercase. So they will define the issue, the impact, and how to resolve it. In our case, it was to have this feature turn enable to true. But as you can see, there's rule sets for IAM and obviously for the AWS, all the AWS services. And not only for AWS services, but also for Azure, for GCP, for Kubernetes. And this is on this website, snyk.io security rules, where you have that checklist. And by using this Snyk IAC test, you can actually check your Terraform files to make sure that you you don't have any misconfiguration within your code base. Cool. So I think we have a better understanding of what is going on now with the modern application, which brings a new risk profile. So we have 10 to 20% of our code base, the code that we actually write, and the rest is comprised of the open source libraries, containers, and IAC. And obviously, we've seen that it's important to have guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is bigger. So as we've seen at the coding stage, we could have the CLI, the ID integration. On your repo, you can have the tool implemented within your GitHub repo, on your CI/CD pipeline. Also, this depends if you're using Jenkins or GitLab pipelines or GitHub Actions. On the production side, also with Docker, your containers and IAC, and also having that visibility on the registry. It's also important to have that DevSecOps feedback loop to empower developers to build the application securely within the entire development process, because we don't want to have silos between the teams. We want to actually work hand in hand between developers and security teams. So let's have a look with the defensive dev, third practice, and tech to consider. So at the OSS level, inventory your open source components just to know what you have within your application. Don't give hackers more tools to expand their exploits. Leverage security tools. We've seen it with Snyk. This improve your OSS security posture. Embrace automation, because you don't want to do all of this manually. You want to eliminate manual activities. Also, include your OSS component in use within your security policy, and also use SBOMs, the software bill of materials, that helps you identify your software package, content, and license data. Let me just showcase how does this work, the SBOM. You can generate an SBOM file through your application. Let me just try on this one. Hopefully that works. So basically, I'm doing a Snyk test with the JSON format using the Snyk to SPDX, and the JQ is packaged to query the JSON format. So it's querying the vulnerability. Hopefully this is working. Yeah, so it's coming back with the SBOM file, and depending if you're using a tool to centralize all the SBOM. So I've been using it on the Node.js goof, and it's produced the SBOM file, which I can just move it to a tool where you might have all your SBOM centralized, but this is good to have that visibility and better understanding. Just wanted to show you that. For the containers layer, don't run as root. We've seen what happened with the image traffic. I was able to actually navigate on the folders, so a bit scary. Also, don't use privileged containers. Drop capabilities and only allow what's needed. You might probably don't need SSH or curl on all of your application. Have read-only root file systems, and deploy from known sources, and also pull from known registries only. Lastly, on the IAC layer, encrypt your secrets. Make sure that you use role-based access control. Have security context to make sure that you're not running as root. Also start with a zero trust network policy, and make sure to enforce those rules using open policy agent like Gatekeeper to have policy control for your Kubernetes, and use the tools that you can find from the Cloud Native Computing Foundation. Cool. So just to finish, I have 3 top tips to end. So the first one is to adopt a DevSecOps approach, or the shift left approach. Obviously, all the stages are important, but it's also important to detect security holes from day one in order to prevent security issues to begin with, and to resolve them as quickly as possible if they do indeed arise. Second, address open source vulnerabilities. We all really love open source software, but it is important to monitor for vulnerabilities, to regularly update and patch your vulnerabilities as quickly as possible. This is critical. And third, security training for developers, because we as developers, we are responsible for pushing the code into production, and it's critical that we receive training or that we understand a little bit more about these vulnerabilities. Obviously, this training should be tailored to the specific developer rules and security needs. And this is actually a good segue to useful resources, and I will end on that note. So, Snyk security resources, we do have a few cheat sheets on a lot of topics, including NPM security best practices, React security best practices. You can have a look at all those cheat sheets, really good advice on them. Snyk Learn is a demo. Depending on your ecosystem, you will have a lesson covering a specific vulnerability, and you can actually try the vulnerability on your browser. The State of Open Source Security 2022, which is a report on the current state of open source software security and methods to address and improve your cybersecurity posture. This is a joint effort between the Linux Foundation Research and Snyk. And our latest State of Cloud Security Report 2022, a report on the cloud risk and security challenges organizations are experiencing. Those 2 reports have really great insights on open source and cloud security just to have a better understanding and better insights of what is going on there. So I'm Sonia Moise. I'm a security senior advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. And you can reach out to me at Sonia Moise on LinkedIn and other social. And yeah, I'd like to thank you for coming and have fun with me this session. I hope you've learned a few things. Hope I didn't scare you too much. But yeah, I just want to say stay safe in your journey to cloud native application security. And thank you, Patch.
Excellent, excellent. Well done. And I feel like even though we do these on a recurring basis, it's always awesome having you host and run them, Sonia, because I learned something new. And so hopefully folks that are watching this, maybe you've seen some of the past stranger dangers before, you learned something new, and you should tune into some future ones just in case, because Sonia might have some more tricks up her sleeve and vulnerabilities to show us. So
Yep.
oh, the sleeves were rolled up. Okay, so you weren't hiding any
Yeah,
tricks there.
yes.
Cool.
Yep.
All right. Well, thanks so much, Sonia. Thank you all for watching and tuning in. If you're watching on YouTube, be sure to like and subscribe if you made it this far into the video and the stream. If you're on Twitch, be sure to follow so you can see more from us on the channel here. We have plenty more live streams on both YouTube and Twitch. And I think we have another one coming up this week, right? With you and Vandana? You're going to do this week in Vandana?
Yeah, this week in VulnDB. Yeah, this will be on
Nice.
Friday.
So keep an eye out for that, folks. Until then, have a good rest of your day and see you later. Bye.
Bye.
Just keep waving.
Sorry.